Today we're looking at section 2.7, solving problems involving more than one right triangle. In our first example, we're going to calculate the side length using more than one triangle, and in this triangle we are going to calculate the length of this side. So we go to our basic formula, which is, we're looking at triangle x, y, y, w, and we're going to go SOHCAHTOA, and we know the angle, and we are looking for the adjacent, so let's box the adjacent, and we don't know anything else, so I'm going to write that down. Don't have another side. Can I figure one out? That's the question. Can I figure one out? And look at the common side. Oops. Common side, which is WY, because that's common to both triangles. So now I'm going to look at my other triangle. So now I'm looking at triangle WYZ, and SOHCAHTOA. And I know the angle is 20 degrees, so I know all of those, and I know the hypotenuse, and I'm looking for what now is the opposite. So I'm going to use sine. So I can go sine theta equals opposite over hypotenuse. Sine of 20 equals, we need to label this something, let's label it lowercase x. So sine 20 equals x over 8.4. Okay, pull out my magic algebra pen. I need to multiply this side by 8.4. I need to multiply this side by 8.4. And I'm left with 8.4 sine 20 equals x. So my calculator will tell me that x equals 2.87. Let's do a DIMS. Does that make sense? 2.87. That's reasonable. Now remember, I'm keeping all of the decimals in my calculator for the 2.87. I'm just only writing down the 2.87. Now I need to go back to my other triangle. So I'm back to triangle WXY, and I'm talking about angle Y, SOHCAHTOA. So I know the angle, so I can circle the sine, cos, and tan, and I know the hypotenuse. I'm looking for the hypotenuse, sorry. And now I know the adjacent. So we're going to use cosine. So cos theta equals adjacent over hypotenuse. Cos of 22 equals 2.87 over, should we label this one? Let's label this one W. So that's over W. Oops, not two W's, just one W. Over W. Magic algebra pen, we have to get the W on top, so we're going to multiply it on that side. Those cancel. We're going to multiply this side by W. And now we have W cos 22 equals 2.87. Divide that side by cos 22. Divide that side by cos 22. Those cancel out. W equals 2.87 divided by cos 22, which my calculator tells me is 3.098, which I'm going to round to 3.1 centimeters. Because the question asked me to round it to 1 decimal place. And is that reasonable? Yeah, that's reasonable. Okay? So it's a matter of figuring out what you need in order to do what they've asked you to find. And sometimes you have to go hunting for it. Okay. Example 2. Solving a problem with triangles in the same plane. This means that they are flat. You can draw them on a paper. The last one was also in a plane. A surveyor stands at a window on the 9th floor of an office tower. He uses a clinometer to measure the angles of elevation and depression of the top and the base of the taller building. That means that he measured this angle 31 and angle 42 degrees with an instrument, which I'll show you in class. The surveyor sketches this plan of his measurements. Determine the height of the taller building to the nearest tenth of a meter. So I'm going to just redraw this. This height is 39. This is 31 degrees, and this is 42 degrees. Oops, can you read that? 42 degrees. And I need to find, I'm going to label this HT. Oops, HT. And this piece is H1, and this is H2. I'm a big fan of writing out the big picture, and the big picture in this question is that HT, which means total height, is H1 plus H2. Now I actually already know that H2 is 39 because that's a straight line across, right? So it's the same distance as this. So in order to find, so I really only need to find H1. But to find H1, I only know one thing about that triangle. I need to find a second thing about that triangle. I need to find this, again, it's the common side. So let's draw out the triangle. So we're going to draw out our first triangle. This is the bottom triangle because that's the one we know the most about. And we know that this is 42 degrees. And that this is 39 meters, and we're trying to find this distance. So, SOHCAHTOA. I'm not going to do that this time. If you need to do it, you go ahead and do it, but I'm just going to race through this a bit. We're going to use tan. So tan theta is opposite over adjacent. Now, I really recommend that you write that down, even if you're not doing the SOHCAHTOA to figure out which one you're going to use. Write this one down because I've seen so many of you make careless errors on this and they make me sad. Plug in what we know. Tan of 42 equals 39 over x. Multiply this side by x. Multiply this side by x. Pretty soon I'm going to stop doing this too because you should be able to do this quickly. Equals 39. I need to divide this side by tan 42. Divide this side by tan 42. Oops. So I have x equals 30. Whoops. X equals 39 divided by tan 42, which equals 43.314. Is that reasonable? Looking at our drawing? Yep, I'd call it reasonable if this is 39. If this distance here is 39, this being about 39, a little bit more is just fine. So now we can go to our second triangle. which looks like this. This is we've labeled H1. We should be careful about using H's. We don't want to confuse that with hypotenuse. This is 43.314. This is 31 degrees. We're going to use tan again. So tan theta is opposite over adjacent. Tan 31 is H1 over 43.314. We get H1 equals 43.314 tan 31. Now again, you should have kept this whole number in your calculator, and then you multiply that by tan 31, and you get 26.0256. We'll keep that whole amount and drag it up to here. So this equals 26.0256 plus 39, and that equals 65. We can round it now to 65.0 meters. And there's our answer for the total height of the building. And again, we go back and go, does it make sense? Yeah, a little less than twice? Sure. Okay, one more example. Now, this is the confusing example because we are not in a plane. And I will go over this example in class as well with some handy-dandy foldable things that I can show you. Okay, so communications tower. This one's not too bad because it is drawn for you. Communications tower is 35 meters tall. There's the tower. There's the 35 meters. From a point due north of the tower, Tanis measures the angle of elevation to the tower is 70 degrees. So this is north. And her brother, who is due east of the tower, is here, measures the angle of elevation as 50 degrees. How far apart are they? Now, the key to this is that if this is north and this is east, this angle is 90 degrees. So we actually have three triangles here. So I'm going to label, I'll do this in red, I'm going to label this angle, or this side is A, this side is B, and this side is C. So let's draw out the three triangles that we have. There's one triangle that goes like this. This is leaf out here, and this is 50 degrees. And this is side A equals 35 meters. And this is a right angle. And then we have this triangle here, where this is Tanis out here. And this is 70 degrees. This is 90 degrees. This is A equals 35 meters, right? Can you see that? And then we have one more triangle down here at the bottom, where this is 90 degrees. This is where leaf is. This is where Tanis is. And we need to find that side. We don't know anything about the angles at the L or the T on that third triangle. So what we need to do is use, let's label this triangle 1 and triangle 2, where you need to find, hold on, let me finish labeling this. This is B, and this is B, and this is C, and this is C. So if you can't see that, I want you to pause the video and take a look at that until you can make some sense of it, or at least give it a good try. I'm going to continue on now with finding B. It's the first thing we need to do is find B. Because if we can find B and C, we can use Pythagoras to find the distance between L and T. So to find B, this is a tan question, so I'm going to go tan theta equals opposite over adjacent. Tan 50 equals 35 over B. B equals 35 over tan 50. B equals 29.36848709. And we probably should write down all of that because, or store it in your calculator's memory, because we need to find another number now. Storing that in the memory won't help us because we are going to have or if you only have one memory on your calculator, you should write it down. Just trust me on that. Okay, let's let's find C now. This is also a tan question. Tan theta is opposite over adjacent. Tan 70 equals 35 over C. C equals 35 over tan 70, which equals 12.7389582. And so we've got B and C, so we can find this. Let's label this, let's call it D for distance. So Pythagoras tells us that B squared plus C squared equals D squared. B, I'm going to just write in 29.368 squared plus 12.739 squared. But you need to use the full number in your calculator so that you're not going to have a rounding error. And this equals D squared. So I get D squared equals something. I didn't write it down. And then I take the square root of that and the square root of that. And D equals 32.0 meters. The answer is that they are 32 meters apart because we were asked to round it to the nearest whole meter. Okay, and it says in the instructions the diagram is not drawn to scale, so looking at the diagram is not going to help us for the does it make sense. We just have to trust that we did it right. Or maybe draw it to scale, but I don't know how to draw something like that to scale. Okay, that's it. See you in class.